a heat vulnerability index for Salt Lake City, Utah. Vulnerability to extreme heat events is not evenly distributed throughout Salt Lake City. Extreme heat events, or EHE, cause significant morbidity and mortality in the United States. Urban populations are especially at risk due to the urban heat island effect and climate change. To increase the adaptive capacity of cities and their citizens to weather these events, cooling centers and other emergency services should target the most vulnerable. The Heat Vulnerability Index, or HVI, is a tool used frequently in the literature to spatially identify groups vulnerable to EHE. Heat vulnerability changes over time as population and climate change, necessitating updated HVI maps. The most recent HVI for Salt Lake City was published over 10 years ago by Reed et al. In 2009. Salt Lake City has yet to address heat adaptation in its Climate Positive 2040 Joint Resolution. The objectives of my project were to develop an updated heat vulnerability index for Salt Lake City using publicly available data in a geographic information system, or GIS, and apply hotspot analysis to spatially identify vulnerable populations and areas for intervention. Based on the study by Reed et al., 6 factors representing sensitivity, exposure, and adaptive capacity to heat-related morbidity and mortality were mapped. Figure 1 shows 3 socio-demographic characteristics and diabetes prevalence that were mapped and analyzed. Figure 2 shows zonal statistics that were performed on a raster from the National Land Cover Database, or NLCD, to calculate the majority impervious surface for each census tract. Figure 3 shows network analysis that was performed on geocoded cool zones, which is what Salt Lake City terms as cooling centers, to create service areas representing 2, 4, 6, and 8-minute driving time. Quartiles were calculated for each factor to indicate increasing vulnerability. Values were summed to produce an HVI score out of 24 for each census tract. This map can be found in the top left. The Global Moran's Eye tool measured spatial autocorrelation for the factors representing sensitivity, exposure, adaptive capacity, and indicated that a fixed distance band was the appropriate conceptualization of their spatial relationships. Figure 5A is a hotspot analysis on the HVI that shows statistically significant spatial cluster of high scores in the south central area of the city with 95% confidence, and of low scores in the west central area of the city with 90% confidence. Figure 5B is a hotspot analysis of majority impervious surface that shows high scores in the center of the city. Figure C is a hotspot analysis of cool zone access showing high scores in the northwest and southeast of the city. Figure 5D is a hotspot analysis of sociodemographic vulnerability, including diabetes prevalence, showing clusters of high scores in the south central area of the city. The mean HVI score was 14.55 with a standard deviation of 3.56. The median score is 14, the highest score was 22, and the lowest score 8. This index and subsequent spatial analyses can be used by urban planners and political leaders to design policies and programs to minimize heat-related hazards in Salt Lake City. Possibilities include, in South Central Salt Lake City, cool zone access that exists, but significant sociodemographic vulnerability. These communities might benefit from at-home heat mitigation interventions, including the provision of AC units and fans, electricity subsidies, and multilingual education on proper hydration and the availability of heat mitigation resources. The northwest and southeast of Salt Lake City, there is cool zone access, but it's limited. New cooling centers may be indicated, but additional considerations should be made, including the hours and capacity of present cool zones. In downtown Salt Lake City, they likely experience the highest ambient temperatures. This is an area that would benefit from green roofs and the planting of trees to curb the urban heat island effect. I would like to acknowledge my professor, Dr. Kevin Lane, as well as my teaching assistant, Paige Brochu, and my classmates in EH 851, without whom I could not have produced this project. Thank you.